womb, or our heads would never get through the birth canal. A long, slow childhood gives our brains time to grow after birth, and time to learn everything we need to function in our complex human societies. That's the advantage of prolonged childhood, for us at least. But what about Turkana Boy? His brain was 900 cubic centimeters, smaller than ours, but more than twice as large as a chimp's. So was he on the way to thinking and talking like us? Ralph Holloway believes he was. He's been collecting the brain endocasts of human ancestors for over 30 years. An endocast is a mold taken from the inside of the skull, which reveals the shape of the brain. Ralph is particularly interested in something called the Broca's area.
Broca's area is involved with memory functions, executive functions, but it does have a very important role to play in the motor aspects of speech.
In the brain of Turkana Boy, Ralph believes he sees evidence for something remarkable. A change in the Broca's area tied to communication.
Broca's caps regions on the Turkana Boy are fully modern in terms of their appearance. It is good, solid evidence for having the ability of symbolic communication. In other words, language.
It's a controversial idea, and we'll never know for sure if Turkana Boy could speak. But there are other clues to his intelligence. The stone tools he left behind.
Homo erectus made tools like this hand axe here. It's been chipped extensively on both sides. The point enables one to do piercing tasks. The heavy bit here can be used for cracking bone or chopping wood. It's a very, very versatile tool and a sharp one.
It may not look like much, but the stone hand axe marks the birth of technology. Homo erectus has left us many signs of his inventiveness. Here in central Kenya, Rick Potts has been studying a treasure trove of Homo erectus stone tools.
Stone tools represented a momentous change because once you had tools in your hands, all the foods in the world could open up to you. That represented a tremendous survival advantage.
Here is a cache of over 500 stone hand axes made by Homo erectus. Just a mile away, Rick visits the quarry where for thousands of years, these ancestors came to shape stone into tools, leaving behind unused fragments.
In the crevices at my feet, there were thousands of fragments of stone from tool making. And there were several scars where Homo erectus struck huge flakes. We also see evidence that they could recognize flaws. They could see which ones would break if they took them away. So they simply discarded them here. What's amazing about that is you could imagine an early Homo erectus sitting right here making decisions.
The kind of decision-making it takes to create a stone tool has been researched extensively by John Shea.
I'm just going to tap it a little bit. I'm just checking it out to see if there's any internal flaws before I do it. There may be one in here. It feels like there might be something in there, but I like a challenge, so I'll nap it anyway.
Even for an expert, making a hand axe is not easy.
Yeah, there's the flaw, but we got around it.
A good toolmaker has to understand the properties of stone.
To make this thing nice and thin, easier to carry, easier to transport, and more to the sharp cutting edge, I'm going to do something kind of counterintuitive. I'm going to dull the edge so that the next time I strike it, it won't fail until I have a lot of pressure on it. Until I've hit it really hard, the fracture will go much further than it otherwise would. So that Homo erectus did this tells us they were capable of thinking ahead, of planning the consequences of their actions. So let's have a look here. What'll happen here?
Many of these stones have hidden defects. Okay. Failing to spot them could spell disaster.
There's still a flaw in there. I can hear it. I can tell, yeah, see this? It's right there. Now, I've worked around it, but if I were an early human and spotted this, I would stop making the hand axe right now. If I'm out running around the savannas chasing a rhinoceros and I'm butchering a rhinoceros as the lions are circling and my hand axe breaks, I'm in trouble. So, you know, I go home tonight, I'm still going to get fed, even though I didn't make a perfect hand axe. As Homo erectus, I might end up being the meal instead, you know.
A skilled craftsman, Homo erectus had evolved a new type of intelligence. But his bigger brain came with hidden costs. Modern brains consume 25% of our body's energy.
Our brain happens to be the hungriest organ in the body. And in order to support a brain our size, we need lots of calories.
With his big brain and body, a Homo erectus like Turkana boy needed more nutrition from his savanna environment.
Turkana boy, had he grown to adulthood, would probably stood around 6 feet tall. This is a big, strong creature that would have had a huge energy budget. One can satisfy an energy budget like that by eating plants, but you have to eat a lot of plants.
But there's one food that can supply the nutrients a growing brain and body need. And Africa was filled with it.
The one high-quality resource that's probably most important for the evolution of the genus Homo is meat, and meat byproducts such as brain and marrow and fat. They're high in protein, they're high in calories, and they're easy to digest. But the one problem with getting meat is that it's hard to get.
Most predators rely on strength or speed to kill their prey. Our ancestors had neither. Today, we are on top of the food chain, so it's hard to imagine the predicament of those early humans. Here was a slow-moving creature with no claws or fangs, easy prey for the hungry predators around him.
This is a fossil forehead and brow ridge of a Homo erectus. And on the brow ridge, you can see the bite mark of a carnivore. Well, this reminds us that these Homo erectus individuals weren't at the top of the food chain.
So how did Turkana boy, a weakling with a big brain which needed calories, get his meat?
Homo erectus faced a problem. How do you kill a big, dangerous animal that has lots of meat and fat in it without that animal also killing you?
I think the answer to that was a very clever set of innovations, and that is endurance running and high activity in the middle of the day.
The ancestors of Homo erectus, small, hairy apes like Lucy, were bipedal, but probably didn't do much running. But Turkana boy's kind were built to run, like us.
This is an accelerometer. It weighs
Dan Lieberman believes they could run long distances because, like us, they had lost their thick coat of body hair and could keep cool by sweating. This was the key to their success. But how do we know if these crucial changes go back all the way to Turkana boy's time, over 1 million years ago? Skin and hair are rarely preserved in the fossil record. So to find out, we have to look to a creature that's been intimately connected with hair for a long time, the louse.
All animals seem to have some type of lice that parasitize them. Mammals have them, birds have them, even fish have types of lice. But most other creatures have only one type of lice that parasitize them.
Humans have one kind of louse on their heads and another in the pubic area. Geneticist Mark Stoneking asked himself why.
The answer that seems obvious is that when we had body hair all over our bodies, we had one type of lice, but then we became hairless until we only had hair on our heads and in our pubic region. And so therefore you would have this hairless geographic barrier to contact between the two.
Mark was surprised to find out that the human pubic louse is very different from the human head louse. Somehow, in the past, it seems to have come from gorillas.
Because the pubic lice is actually more closely related to gorilla lice. Now, how it is our ancestors got pubic lice from gorillas, I wouldn't care to speculate. But nonetheless, one needs gorilla lice in order to really work this whole thing out.
The most likely scenario is that when we lost our body hair, the original human louse migrated to our heads, leaving the pubic area temporarily unpopulated by lice. When our ancestors had contact with gorillas, perhaps sleeping in their nests or scavenging their bodies for meat, the gorilla louse colonized their pubic region. Eventually, it turned into the human pubic louse of today. So if we could find out when the human pubic louse and the gorilla louse diverged, we would have a rough idea of when we lost our body hair. Fortunately, there's a way to figure that out. The genetic dating technique known as the molecular clock. It's based on the fact that the sequence of chemical bases which make up DNA mutate at a regular rate.
It's just a very simple idea that the rate of change in DNA sequences is more or less constant over time. And that means that you have a way of determining when two species last shared a common ancestor.
By counting the number of differences in the genetic code of two species, scientists can determine how long they've been evolving away from each other. When Mark used the molecular clock to count the differences between the DNA of gorilla lice and human pubic lice, he came up with a date for their divergence.
The estimated date for the divergence is roughly 3 million years ago.
That means long before Turkana Boy, maybe even around Lucy's time, our ancestors had slowly begun to lose their body hair. Turkana Boy was mostly hairless, just like us. And that may be what gave him an edge over other predators. Most animals are at a disadvantage in the midday sun because they overheat. They can only cool down by panting. And when they run fast, they can't pant. That means they can only run in short sprints.
Quadrupeds can gallop for about 10 to 15 minutes, and then they overheat. But hominids can cool down by sweating. They use their entire body like a dog's tongue.
Our hairless bodies allow air to circulate freely on our skin and cool us down as sweat evaporates. This makes us one of the best long-distance runners in the animal kingdom. Dan Lieberman believes this gave our ancestors the ability to hunt in a very unusual way. It's called persistence hunting. And he believes the modern ethnographic record can show us how it was done. The Bushmen of the Kalahari offer us an insight into how Homo erectus might have hunted 2 million years ago. The Bushmen know that at midday, animals rest in the shade, which is why it's the perfect time to be hunting. Once they locate their prey, in this case a kudu, the marathon begins. Their strategy is simple: run it to exhaustion. Every time the animal tries to rest, the hunters track it down and get it moving again. They never give it a chance to cool down. And the reason they can keep going is that they can sweat. So if the theory is right, the Bushman hunt may help explain how Turkana Boy got his meat. Homo erectus had come up with an innovative way of feeding his hungry brain. In this modern hunt, the Bushmen ran in the fierce heat for over 4 hours. The kudu was finally immobilized by heat stroke. Turkana Boy wouldn't have had steel-tipped spears like the Bushmen, but he wouldn't have needed them.
Homo erectus probably hunted with close quarters weapons, with spears that were thrown at animals from a short distance, clubs, thrown rocks, weapons like that. They weren't using long-distance projectile weapons that we know of.
The Homo erectus hunt was simple but effective. It fed not just their larger brains, but the growing complexity of that early human society. There are other social animals, but none quite like us.